Hello. Welcome back to Learning Chemistry with Jaya. Now, today, we are going to talk about IGCSE level chemistry, chapter 1, particulate nature of matter. Now, for this chapter, I will separate the video into two parts, and now we are going to talk about part 1. Okay? Now, without further ado, just let's get into it. Okay? Now, what we are going to learn in this chapter, which is particulate nature of matter. Now, from the title of the topic, we already know that we're going to talk about how matters behave naturally. Yeah. For that, we need to get to know about matter first. What is matter? Okay. Now, maybe some of you have learned this from physics or chemistry in the previous level. All right. And do you have any idea about what matter is? Okay. Matter can be defined as anything that has mass and occupy space. Correct. Yeah. Well done. Okay. Matter is anything that has mass and occupies space. So anything around you in the universe, even if it has mass and also occupies, this should be occupies, yeah, occupies space, then it is classified as matter. Now, what are the example of matter, you ask? It's very simple, actually. Like you can see around you, things around you, and most likely it will be classified as matter. For example, water. Water is classified as matter. Why? Because it has mass and also it occupies space. That's why if you put water into a container, let's say a bottle, then it will mold it, right, into the bottle itself, the bottle shape. That means that it occupies space. How about salt? Salt is also a matter because it has mass, yeah, and it also occupies space. And what about you? What about us? Are we matter? Are we matter? Yeah. Not do we matter? Of course do we matter, but are we matter? Yes, we are also matter. Either salt and us, and we are also matter, right? Because I weigh like 76 kilograms, right? That means that I have mass, right? And how about your weight? Just put some comment into the comment section, okay? Now, what is the example of non-matter, you might ask? It is the example of non-matter. The thing that is not classified as matter is this. What is this? Yes, correct. This is light. Light is not considered as matter because we can't really weigh the mass of light, right? And it also doesn't occupy space. Yeah, we can contain a light in a container. That's why it doesn't occupy space. All right. Now, do you understand about what we have already talked about? Okay, good. Now, We're moving on to the second part of this. I mean, the second section of this video, which is the state of matters and the nature of the particles. Okay, now I want to ask you about the state of matter. What are states of matter exist in the nature that you know, yeah? Okay, so it is solid. They are solid, and then liquid, and also gas. Okay, good job. Now, what are the differences between solid, liquid, and gas? Okay, we can make three perspectives to observe the differences between solid, liquid, and gas. Yeah. As we can see here, I have already inserted some pictures representing the particles in the three states, yeah, solid, liquid, and gas. As you can see here, this is the particles in solid state. This is for the liquid state, and it is for the gas state. Okay. Now, we can see the differences from three perspectives to make it easier to understand. Okay. Now, for the first perspective, we can see the difference from the perspective of the arrangement. Sorry, the arrangement. Now, I want to ask you, let's discuss actively here, right? How is the particles, how are the arrangement of particles in the solid state? From this picture, you can observe. Yes, correct. The particles in solid will be ordinary, not ordinary, but in the very regular. Yeah, I think it's more suitable. Yeah, regular pattern, or they're regularly arranged. Yeah. And then how about particles in liquid? Yeah, as you can see here, the particles are not in the regular pattern as in solid. Yeah. Instead, they are becomes irregular. Or irregularly arranged. How about in gas? Yes, from the picture we can see that they are randomly arranged. Okay. Now, they those are the differences in the arrangement perspective of the particles, of course. Yeah. And then we can move on to the second perspective, the distance between particles. Yeah. Remember, this is the distance between particles. Okay. Now, let's start with the solid. As you can see here, the particles are very closely packed, right? So we can call it as closely packed. Okay, packed. It should be packed. Okay, it's very closely packed. And how about in liquid? As you can see here, the particles are very close to each other. Yeah, but they are, or you can say that they are touching each other. But you can also answer it just closely together, yeah, closely to each other. And now for the gas particles, as you can see here, the particles of gas are very far apart. They don't touch each other. They do collide with each other, but they can't be said they are touching with each other. Okay, as you can see, there are spaces between particles. That's why we call it far apart. Okay. Now, how about this third perspective? The third perspective is the movement. Now, for the solid, we can see here from the picture. Yeah. Yeah. No, we can't see from the picture because the picture is not um, in motion. Yeah. But just view it in your head. Yeah. The particles in solid are not moving. They don't move at all. They don't move at all. Instead, they are vibrating. So remember, all particles, yeah, all particles in any state, yeah, they are in motion. They are always in motion. But for solid, they don't move. So the motion that the particles of solid do is vibrating. So they are vibrating. Maybe I should draw it like this. They're vibrating like your phone when it vibrates. Okay. Now, how about in liquid? The particles in liquid, they are sliding over each other. Or you can also say passing over each other. That's okay too. The thing is, they move like balls in ball pool. Imagine like you have a big pool of balls, yeah, and then you try to move the balls inside the pool, and then you can see that the balls move sliding over each other. That's how the particles of liquid move. Okay, so remember, in the solid form, the particles don't move at all. They're just vibrating. So they stay in place, yeah, in solid. While in liquid, they start moving by sliding over each other or passing over each other. So they can move freely at random direction. Yeah. Meanwhile, gas, they can move it randomly or move at any direction. So up, down, left, right, forward, backward. They can do whatever they want. They just a rebel, you know. So the particles in gas can move randomly at any direction. So these are the differences between particles in three different states. Okay. Now we're moving on to the change of states. Now, as we can see here, we've still got the pictures of each particles in three different states. Yeah. Now we want to know the name first for each change. Okay. Let's start with the change from solid to liquid. What is the name of change from solid to liquid? Yes, it is melting. Correct. Now, how about the reverse process? What is it called? Yes, from liquid to solid, you can imagine it like liquid water turned into ice. It is freezing. Correct. Now, how about liquid turns into gas? Imagine you have water and then you try to heat it with stove or something and it turns into gas. What is it called? The process. Yes, it is evaporation. Sorry, I need to change the color of my pen. Wait a sec. It is evaporation. Is there another name for this process? Yes, it can also be called as boiling. Are they the same? Not exactly. Let's discuss the differences between evaporation and boiling later. Okay? Now, let's just know that this process is called, the process of liquid turning into gas is called evaporation or boiling. Okay? Now, what is the reverse process? Imagine you have like water vapor turns into liquid, back into liquid. What is it called? Yes, it is called condensation. Okay. Now, how about solid turns into gas directly without going through liquid phase. So it's all the way to gas, solid all the way to change into gas. It is called sublimation. Yeah, sublimation. So what is the example of sublimation in daily life, you might ask? If you have like what is it called, a camphor, no, camphor or mothballs. Yeah, if you have mothballs in your home, you might notice that the solid mothballs will get decreased in size as the time passes by. What happens to it? And you don't notice any liquid forms, right? So the mothballs decreasing in size, that is the sign of sublimation. So the mothballs are subliming. They turn, sorry, they turn into gas all the way through. Okay, that is the example of sublimation in daily life. Now, what is it called? The reverse process. Yes, this is also called sublimation. Okay, so from solid to liquid, from solid to gas and gas to solid, they are called sublimation. Okay, up until this point, we already know the name of each process. Alright? Now, not only that, it's not enough. We need to know what happens to the particles when there's a process happen. What does it mean? Like this. What happens in the problem? You might be asked, what happens to the particles when ice melting, for example? When ice melts. So we already know that ice is solid, all right? And when it melts, it means that it turns into liquid state, all right? Now, what happens to the particles when the ice melts? Now, again, we can see it from the three perspectives that we have already learned before, which is the arrangement, the distance, and the movement. Some problem will specify what they want you to answer, what perspective you are demanded to answer. Okay, now if it's general here, so what happens, not what happens to the arrangement or what happens to the uh, movement, for example, you can answer in one perspective. You just choose between these three perspectives. Okay, so but for now, maybe we have to see it from the three perspectives. Let's start with the arrangement. What do you think happened to the arrangement of particles when ice melts? Okay, they become irregularly arranged. Okay, that is very good. As you can see here from the picture, in the solid forms, they are in irregular patterns or they are regularly arranged, correct? Now in the liquid, they start to arrange irregularly. So that by that, it means that the arrangement, when ice melts, they become irregularly arranged. Okay, got it? Good. Now let's move on with the another perspective, which is the with the distance between particles. What happens to the distance between the particles when ice melts? From here to here. Nice. The distance become become farther? Okay, the answer is they become, or the distance between particles become farther. Okay, although it is, we can barely see that there's spaces between liquids, but in the reality, there are distances between liquid particles. Yeah, but it's it's very small compared to the distance between gas particles. But there are distances between particles in liquid, but not as wide as the gas. Okay, so that is the distance. Now we see from the perspective of movement. What happened to the particles of ice when it melts? Yes, as you can see here, in the solid form, the particles don't move at all. They're just vibrating. So they stay in place. While in the liquid form, they start to move, correct? So the answer for this is they start moving. Okay, now we come to the end of our video. If you have any questions regarding what we are learning today, you can ask me in the comment section below. Okay? By then, see you on the next video.